date is the 6th of November. All right. All right, so, sorry, 20-second delay here. So, rational numbers. Let's look at our different kinds of number systems. Well, we've got really one number system, the real number system, that we deal with in here. So, let's look at what makes up our real number system. What are natural numbers? Natural numbers. David. 1, 2, 3. We call those all of our counting numbers. They are all of our counting numbers. 1, 2, 3, 4, so on. Then we get to whole numbers. How is a whole number different than natural numbers? Jorge. Okay, it has all of the natural numbers, and it also actually involves 0, as Jorge would say. Okay, whole numbers are 0 and all the natural numbers. 0, 1, 2, 3, 4. Then we've got our integers. Integers. What are our integers? Tiffany? Okay, positive and negative numbers. Yes?
Positive and negative natural numbers.
Natural and whole numbers. The reason why it includes whole is because 0 is in there. Sorry, that was my water. So integers are whole numbers and their opposites. And last but not least, we've got the granddaddy of them all, Mr. Rational himself, rational numbers. Okay? Rational numbers include integers, whole numbers, natural numbers, and fractions and decimals. Okay? The definition of a rational number is any number that can be written as a ratio of two numbers. And also, we can say that that's the fancy way for saying any number that can be written as a fraction. So, this includes all fractions, decimals, percents. What kind of decimals? Terminating and repeating decimals. Terminating and ending decimal. 0.3 ends. It has an end. Okay? And a repeating would be 0.3 repeated. Okay? Okay, so now, I'm going to kind of skip over this. Any number that can be written as a fraction. The fancy way they say that is any number that can be written as a quotient of two numbers. A ratio of two numbers. Those are just other ways to say fraction. So what did I say a fancy way to say fraction is?
The quotient of two numbers.
The quotient of two numbers. Give me another way to say fraction in academic language. Yes?
A ratio.
The ratio of two numbers. Okay, these are the kind of words you're going to want to use on your Common Core assessments. That will get you extra points. Okay, I'm going to show you the diagram one more time. Remember, we've got our naturals. Our whole numbers include the naturals and 0. Our integers include all the wholes in the naturals and the negatives, the opposites. And then we've got our rationals, which are inclusive of everything in the center and the decimals. And repeating decimals too. I'm going to skip this next part because we did this before. Do you remember?
Yeah.
Where we identified what is rational, what is...
Yep. Oh.
Okay, so I'm going to skip this part of it and go right on to the second part of this, which is converting fractions to decimals and decimals to fractions. All right, so if I'm converting fractions to decimals, if I have a number like 3/8, actually let's do something even easier, okay? Let's do something easier. I like to do this because I'd like you to convert that to a decimal. What is the process I use? That's why I like to say that. What is the process I use? Because the majority of people just want to give me the answer. I'll give you the answer. 1/2 is equal to 0 and 5/10. Now, my question is, how do I convert it to the decimal? Sarah? Division. Okay, so what am I dividing?
You're dividing 1 by 2.
I'm dividing 1 by 2. So what goes into my division box? 1. I put the top dog goes in the dog house. And then 2 becomes the divisor. 1 is the dividend, 2 is the divisor. And then I add a decimal and as many zeros as I may need. Next step. Sergio.
You connect the 0 with the 1, and then you see how many times the 10 is. How many times?
I don't connect. What do you mean I connect the 0 with the 1? There's one step we're missing.
Oh.
Eva? Bring up the decimal. And then we say to ourselves, how many times does 2 go into 1?
So you add the 0.
We add a 0. But now I can look at how many times does 2 go into 10. Sergio? 5 times. And 5 times 2 is 10. I do the subtraction and I'm left with 0. Do I need to bring another 0 down if I have 0 left?
No.
So I'm good. 1/2 is equal to 0 and 5/10. Okay, questions? Now, I'd like to see you do that with 3/8. Go. Pause the recording and do that with 3/8. Start us off.
You do 3 divided by 8.
3 divided by 8. Which one goes in the dog house?
3.
The top dog goes in the dog house. Okay.
And then it doesn't get divided into it, so you put a 0.
Okay, what do I do with the decimal? Move it where?
You put it up.
You bring it up. Okay? Sergio, that's the only moving that gets done is you bring it up.
Okay.
Okay? A number naturally has a decimal on the right. Okay? Like think of $3. Where would the decimal be? 3 to the right. Okay, now what am I doing first?
8 goes into 30.
8 goes into 3 0 times.
Yeah.
And then 8 goes into 30 3 times.
And then it's 24.
And then what?
It's 24.
It's 24.
And there's 6 left.
Subtract. We have a remainder of 6.
And then it goes into 60.
Bring down the 0. Don't forget your steps.
And then it goes into 67 times.
Okay?
And that's 56.
Okay. And the remainder is?
4.
Okay.
And then you bring
How long do I keep going? When do I get to stop? Jessica.
If there's 0 remainders or if the opposites repeat itself.
Okay. So I'm going to keep going and I have a remainder of 4. Bring them in another 0. Goes 5 times. I'm finally left with no remainder, so I can stop. Okay? Okay. Now, we're going to go from a decimal to a fraction. How do you say this decimal? How do you say the decimal? Alasia. 375 thousandths. Can we speak decimals at this point? If you can say it, you can convert it. 375 thousandths. Okay? That means it goes over what?
1,000.
So that's 375 over 1,000. If you can say it, you can write the fraction, 375 thousandths. Now, all you have to do is, so any fraction, if decimal, you can say it, you can convert it to a fraction. Now we just have to divide it. Now, I don't generally, a number this big, I don't use the greatest common factor. I just find a common factor. And what this number reminds me of is money. $3.75 and $10. What unit of money divides into them evenly? Pennies, dimes, quarters, nickels, dollars. A dollar divides into 375 evenly? So let's go with quarters. So if I divide 375 by 25, what do I get? What this is basically asking me is how many 25s are there? How many quarters in 375? So in $1, how many quarters are there?
4.
Okay. In $2? In $3?
12.
And then I have 75 more cents. How many more quarters is that?
3.
So 12 and 3 is 15. Okay. Now, how many quarters in $10? In $1 it's 4. $2?
8.
3?
12. 16.
20? 36? And 40. So 40 quarters. Am I done? Is it reduced? What else can be divided into both parts, Olivia? 5. 5 goes into 15 3 times, and 5 goes into, and look where we end up, back at the reduced fraction. Now, can anybody tell me, based on this work, what is the greatest common factor? Is 25 the greatest common factor?
No.
So, how would I find the greatest common factor? It's very easy. It's right there. So I divided by 25. And Sarah?
You multiply 5 and 25.
And I divided by 5. So 25 times 5 is 125. That was the greatest common factor. The greatest common divider. I just used common factors, 5 and 25. If I multiply them together, I get the greatest common factor. Okay? All right, so explain the process, how to convert a fraction to a decimal. Who can describe for me the process of converting a fraction to a decimal? David. Okay, who can explain the process? How to go from fraction to decimal? What do you have to do? Nobody remembers? Josh.
You have to divide the dividend by the divisor.
Okay. Dividend by the divisor. How do I know which is which? What would we identify here? The numerator by the... Yes. That's how we get the decimal. And how do I convert from a decimal to a fraction? What's the rule in going from decimal to fraction? Anybody? Sarah?
You say it right and then you put it like 7.
Okay, if you can say it, you can put it into the fraction form, and then you reduce it. That's it. All right, let's try. Yes.
If it's a mixed number, do you convert it
Ah,
to improper fraction first? Or do you keep the whole number in the mixed?
you have two methods. It sounds like you know both of them. What are you most comfortable with?
Keeping the whole number?
Keeping the whole number whole and just converting the fractional part. So on 6 and 7/10, can we convert that? 6, say it. Can you say that?
Yeah.
6 and 7/10 then becomes 6 and 7/10. Okay. And here, all you really need to do is convert the fractional amount. So it's going to be 4 point, you're dividing just the fractional part. Okay, finish the table. Go. All right, so let's go back. I forgot, and I just kept going. Now it's stuck. There we go. All right, I just want you to check your answers on the chart. We have 300ths. If you can say it, you can write it. The first one is 8/10. The third one is 3500ths. The fourth one is 6 7/10. Again, if you can say it, you can write it. And the last one, all I really did was divide the denominator into the numerator. Okay, repeating decimals. If it is a fraction, I divide the denominator into, what's going on? I divide the numerator by the denominator, and I start to see a number pattern. Not quite sure what's going on there. We put what's called, does anybody know what that line is called? The repeat bar. We put the repeat bar. Yes. I know what it is, but it has a special name. Okay, so we put the repeat bar over the first sign of the number. And then, so it only goes over that first digit, not the 33. I don't need it to go over 2 digits. Yes, Michaela.
So if you have a repeating decimal, you can't make it into a fraction?
Absolutely you can. Repeating decimals are fractions. That's the point here. Did I go from 1/3 to 3.3 repeated?
Yeah.
Then you can go the other way too. All repeating decimals are rational numbers. They can be written as fractions. Okay, I'm going there now. I think I'm going to have to pause this. There we go. Same thing here, just a reminder. If I'm doing it, I divide the denominator into the numerator. And you will see, I don't know why it's going wonky again. Okay, now in this case, what's repeating? So how do I show that? Just that. Jorge. You put the bar above the 2 numbers that are repeating. Do I put it over 3 numbers? No, only the first ones that repeat. Once I see the 4 again, I don't write it. Yes.
I was going to ask, so you don't need the 4?
No, we don't need that third 4. Okay, it's moving wonky again. Okay, now this one's a little bit different. When I do the dividing, look what happens. Come on, little Mr. Wonky. That's this computer. What's going to happen here? What's happening? Where does my repeat bar go? Alejandra.
Over the first 3.
Over the first 3 only. Okay, now, let's look for a pattern. Let's see if you guys can figure out this pattern. Come on. Going awfully wonky. No, it has it's called like a Coluche. It has a very specific name. Josh, hurry up. That's not the mathematical term. You know who knows it? Miss Sophia. Miss Sophia knows the name of it. Oh, come on. All right. Okay, now repeating decimals. See if you can follow the pattern. When I have 0.1 repeated, it's 1/9. If I have 0.2 repeated, it's 2/9. 0.3 repeated is 3/9, which reduces to 1/3. That's one that you should have memorized, that 0.3 repeated is equivalent to 1/3. 0.4 repeated is 4/9. So the pattern. The pattern is, whatever it is repeated goes in the numerator, and it's always over 9. Repeats always go over 9, so it would be 5/9. Then 6/9. 6/9 can be reduced to 2/3. Next, it would be 7/9. 8/9. And then 9/9, which pretty much reduces to 1. Now, if you have more than one digit repeated, then it goes over more than 1 9, 2 9s. 2 digits repeated, 2 9s. 2 digits repeated. The one thing you have to remember here is sometimes you have to simplify. Make sure that gets done. Ivan, stop it. That's my dog. 3 digits repeated over 3 9s. And if 4 digits repeated, it goes over 4 9s. If you only have 1 out of 2 numbers is repeated, you get to skip that tonight because that involves a whole lot of math, and that will take more than just right now to do it. All right, and that's the lesson for today.